Hello, everyone. Uh, this is my first online class for Maths 180. Today, I'm going to teach 3.5, then 3.6, and then 3.7 separately. And then I posted on the Canvas. Again, guys, please be patient with me. I know this is a completely new, not only for you guys, for me also. I never done this before, so I do my best to do this. So on Wednesday, so the things that I'm going to do, I'm going to post these online for 3.5, 3.6, and 3.7. Wednesday, I'm going to make an announcement. I'm create a discussion board on Canvas, and please, guys, everyone, be on Canvas from 5:35 to 7:30 p.m. And then I'm going to take attendance, and then based on these lectures, I'm going to ask you do some problems, and then we work on it, and you guys give it to me the answer. So in the discussion board, you guys can talk to each other, work with each other, and we go from there. Okay, so let's start with 3.5, implicit differentiation. Okay, guys, the step is differentiate both sides of the equation with respect to x. Then we apply the rules of differentiation. If an expression involves y, then include dy dx. Isolate all the dy dx terms on one side of the equation, factor out dy dx, and then we solve for dy dx by dividing. So now let's make an example. So there is an example here in the Microsoft Word sheet that I sent it to you guys on the Canvas for 3.5. So let's do this example together. So we have 2x squared minus 3y cubed equal to 5. Okay, so I'm going to take a derivative of both sides with respect to x. So I'm going to do it separately. So it's going to be the derivative with respect to x of 2x squared minus derivative with respect to x of 3y cubed equal to derivative with respect to x of 5. Okay, so the derivative with respect to x of 2x squared is going to be 4x minus, okay guys, now this is again chain rule, derivative of mother and then derivative of baby. So since this is a y function, so it's going to be derivative of dy dx. So derivative of function y with respect to x, and then we take a derivative of baby that is going to be 9y squared, and then equal to, and derivative of respect to x of 5 is a constant, so it's going to be 0. Now I'm going to isolate dy dx. So the first thing I'm going to do, I'm going to subtract 4x from the both sides, so I have negative dy dx of 9y squared equal to negative 4x. And then finally, I'm going to divide both sides by, because I want to isolate dy dx, I'm going to divide both sides by negative 9y squared. So finally, I have dy dx equal to, so when I divide both sides by negative 9y squared, so negative divided by negative is positive. So my final answer is going to be 4x over 9y squared. So as you guys see that the answer is 4x over 9y squared. And again, guys, as you see in the example, we did the same procedure. So I'm going to did it so you guys, I just did right now, so you guys can see it and follow the procedure. So now let's do a problem together. So if x squared plus y squared is equal to 25, find dy dx. So again, I'm going to take a derivative respect to x of the both sides. So it's going to be derivative respect to x of x squared plus derivative of respect to x of y squared equal to derivative respect to x of constant 25. So again, guys, I'm going to take a derivative of respect to x of x squared. So that's going to be 2x plus, and again, guys, I'm going to use a chain rule since this is a y function. So it's going to be derivative of function y with respect to x. So it's going to be dy dx. And then I'm going to take a derivative of baby. So it's going to be 2y equal to, and then derivative respect to x of a 25. 25 is a constant, so it's going to be 0. Now I'm going to isolate dy dx. So I'm going to subtract 2x from the both sides. So it's going to be dy dx of 2y equal to negative 2x. And then now, again, I want to isolate dy dx. So what's bothering me is 2y. So I'm going to divide it both sides by 2y. So it's going to be dy dx equal to negative 2x over 2y. And then 2 divided by 2 is 1. So finally, dy dx is going to be negative x over y. So the dy dx for this function, if x squared plus y squared equal 25, the dy dx is going to be negative x over y. So now let's go to next example. So find y prime if x cubed plus y cubed is equal to 6 times x times y. So again, I'm going to take a derivative with respect to x of the both side. So, okay, guys, I'm going to take a derivative of x cubed. So with respect to x, so x cubed is going to be 3x squared plus, okay, again, I'm going to take a derivative of y cubed but respect to x. But again, guys, this is a function y, so it's going to be y prime. That's the dy dx. So we take a derivative of mother, and then we take a derivative of baby, that is y cubed. So it's going to be 3y squared equal to, and then 6 times x times y. Actually, I'm going to use the multiplication rule. So derivative of the first function times the derivative of second plus second times derivative of first. So it's going to be 6x times derivative of the second is going to be just y prime. Again, the y is going to be the derivative of the mother, dy dx, that is y prime, and derivative of baby, the y is 1, so I'm not going to write it down. So plus, now y the second function times derivative of the first. So with respect to x, so is 6x is going to be just 6. So now if you guys look at this, you see that all parts of this equation, we can divide it all both sides by 3. So if we divide all by 3, this is going to be gone. So it's going to be x squared plus, and again, if I divided this by 3, so it's going to be y prime y squared equal to 6 divided by 3 is 2, so it's going to be 2xy prime plus 6 divided by 3 is 2, so it's going to be just 2y. And then now I want to isolate, again, we want to isolate dy dx, the other word y prime, okay? So the things that I'm going to do, you see that this y prime y square, and then the other side of the equation I have 2xy prime. I want to bring all these y prime to the one side, so I'm going to say, okay, so y prime y square, I bring this to the other side, so it's going to be minus 2x y prime equal to, then I bring the x squared to the other side, so it's going to be 2y minus x squared. Okay, now I can factor out the y prime. So I factor y prime, so it's going to be y squared minus 2x equal to 2y minus x squared. And then divided, now I'm going to divide both sides by y squared minus 2x. So it's going to be y prime equal to 2y minus x squared over y squared minus 2x. So, and that's my answer. Okay, so now let's go to next question. Use implicit differentiation to find an equation of a tangent line to the curve at the given point. Sine of x plus y is equal to 2x minus 2y in the interval pi comma pi. Okay, guys, again, I want to find the equation of a tangent line. So first we have to find the slope, and when we find the slope, then we use the formula, and then we find the equation of a tangent line. So again, I'm going to use the implicit differentiation. I'm going to differentiate both sides. So again, with respect to x, so if I differentiate this, the sine of x plus y, again, I'm going to take a derivative of mother and then take a derivative of baby. So sine of x plus y, the derivative of sine of x plus y, so it's going to be cosine of x plus y. And now I'm going to take a derivative of baby. So x is, derivative of x is 1 plus y, again, is going to be y prime, take a derivative of mother, y prime, and then take a derivative of baby, y is equal 1. So it's going to be just y prime equal to, and again, 2x is going to be just 2 minus, again, take a derivative of 2y is going to be y prime, and then take a derivative of baby, so it's 2y is just 2, so it's going to be just 2y prime. And then now let's plug it in. So you see that my interval, so x is pi and y is pi, so I'm going to replace it. So it's going to be cosine of pi plus pi, and then times 1. Let me erase this. 1 plus y prime equal to 2 minus 2y prime. So pi plus pi is 2 pi. So it's going to be cosine of 2 pi times 1 plus y prime equal to 2 minus 2y prime. So again, guys, cosine of 2 pi, remember that cosine of 0 is 1. And then when we do a complete cycle, so it's going to be 2 pi. So the cosine of 2 pi is also 1. So cosine of 2 pi is 1. And then times 1 plus y prime equal to 2 minus 2y prime. 1 times 1 plus y prime is 1 plus y prime. So 1 plus y prime equal to 2 minus 2y prime. And now I'm going to again bring all the y prime to the one side and isolate the y prime. So let's see what happens. So it's going to be y prime plus 2y prime equal to 2 minus 1. So it's going to be 1y prime plus 2y prime is going to be 3y prime equal to 2 minus 1 is 1. And finally, y prime divided both sides by 3. So y prime is going to be 1/3. So the slope of a tangent line is 1/3. Now I'm going to use the point intercept form, point slope form, I'm sorry, to find the equation of a tangent line. So it's going to be y minus y1 equal to a slope that is y prime times x minus x1. So y minus y1 is pi equal to 1/3 times x minus pi. So now I'm going to simplify this. So I'm going to distribute 1/3. So it's going to be y minus pi equal to 1/3 x minus 1/3 pi. And then I'm going to add pi to the both sides. So negative pi plus pi is 0. So y is equal to 1/3 x minus 1/3 pi plus pi, because we add pi to the both sides. That part is gone. Negative pi plus pi is 0. The other word, we add pi, the other part. So negative 1/3 pi plus pi. So my equation of a tangent line is going to be y equal to 1/3 x plus 2 pi over 3. And that's the equation of a tangent line. Okay, so now let's do this one. Okay, guys, this one, it says find the y double prime. So this is actually double prime. Find y double prime by implicit differentiation. X squared plus x times y plus y squared is equal to 3. So let's do it. So first I'm going to find the y prime, and when we find the y prime, then I'm going to try to find the double prime. Okay, so let's do it. So if I'm going to take a derivative of the both sides with respect to x. And again, guys, please take notes that x squared plus x times y plus y squared is equal to 3. So just keep that in mind, okay? So let's do it. So if I take a derivative with respect to x of the both sides, so x squared is going to be 2x plus, now x times y, again I'm going to use the multiplication rule, so it's going to be x times y prime plus y times the derivative of x is going to be just 1, and then plus derivative of y squared. Again, guys, I'm going to take a derivative of mother and then the baby, so it's going to be dy dx. The other word is a y prime, and then 2y equal to, and derivative of 3, because 3 is a constant, so it's going to be 0. So now again I'm going to keep the y prime in the one side, and then the rest I'm going to bring to the other side, so it's going to be 2y y prime plus xy prime equal to negative 2x minus y. So now I'm going to again factor out the y prime, so it's going to be y prime, so 2y plus x equal to negative 2x minus y, and again divided both sides by 2y plus x, so the y prime equal to a negative 2x minus y all over 2y plus x. So this is the y prime, but the problem asked me find the double prime. So now I'm going to take another derivative of y prime, and it's called y double prime. So negative 2x minus y over 2y plus x, I'm going to take another derivative. So let's do it. So y double prime is equal to, again I'm going to draw a big line. So so remember that when we take a derivative of a fraction like this, so numerator and denominator, so it's going to be 2y plus x square, okay? And then now I'm going to says, okay, the second 2y plus x, derivative of the first, so second times derivative of the first, so it's going to be negative 2 minus, again derivative of mother y prime, derivative of the baby is 1, so it's going to just y prime minus, now first the numerator first, so it's going to be negative 2x minus y, and then derivative of the second, so it's going to be, again take a derivative of mother, so it's going to be y prime, and then times 2, so it's going to be just 2y prime plus, and derivative of respect to x of x is just 1. Okay, now let's simplify it. So y double prime, so it's going to be 2y plus x times negative 2 minus y prime, and then I'm going to distribute this negative inside of the parentheses. Negative times negative is positive, so it's going to be plus 2x, and then negative times negative is positive, plus y, and then times 2y prime plus 1, and then over 2y plus x squared. Now I'm going to distribute, I'm going to multiply both parentheses plus the second both parentheses and see what happens. So it's going to be y double prime. So 2y times negative 2 is going to be negative 4y. And then minus 2y y prime minus 2x. Negative 2 times x is going to be minus 2x. And finally, minus xy prime. So negative 4y minus 2y y prime minus 2x minus xy prime. And now plus, now I'm going to multiply the other two. So 2x times 2y prime, so it's going to be 4xy prime. And then plus 2x times 1 is 2x, so plus 2x. And then y times 2y prime, so it's going to be 2y y prime plus 2y y prime, and then plus y times 1 is y. So now all over 2y plus x squared. So now you guys can see that so you guys can see that we can cancel something. So but let's make it more clear. So you see that negative 2y y prime and 2y y prime. So negative 2y y prime and plus 2y y prime, that's they cancel out. Negative 2x plus 2x is 0, is cancel out. And then let's see. So and then negative 4y plus y is going to be negative 3y. So y double prime is equal to, okay, negative 4y plus y. So it's going to be negative 3y. So negative 4y plus y is negative 3y. And then what's remaining? Negative 1xy prime plus 4xy prime. So it's going to be negative 1xy prime plus 4xy prime is going to be positive 3xy prime over 2y plus x squared. Okay, so he says, oh, I'm done, Mr. G. So this is y double prime, but look, one of the variable actually is y prime, and we already know that y prime that we find previously about like 10 minutes ago, that is negative 2x minus y over 2y plus x. So I'm going to replace this replace y prime with so I'm going to replace y prime with negative 2x minus y over 2y plus x. So let's do it. So it's going to be equal to negative 3y plus 3x, and then again instead of y prime I'm going to says negative 2x minus y over 2y plus x, and then over 2y plus x squared. Okay, so okay guys, now I want to pay attention that I can simplify this. So let's see what I can do here. So look, y double prime is equal to, so let's say, okay, this is going to be negative 3y over 1 plus, and then I'm going to just multiply 3x by the numerator, so it's going to be negative 6x squared minus 3xy over 2y plus x, and then over 2y plus x squared. Okay, so now I have to find the lowest common denominator between 1 and 2y plus x. So obviously the lowest common denominator between 1 and 2y plus x is 2y plus x. So I'm going to multiply both numerator and denominator by 2y plus x. So it's going to be so the denominator is going to be 2y plus x squared, and then the whole thing, so the denominator is going to be 2y plus x. So if I multiply 2y plus x plus by negative 3y, so it's going to be negative 6y squared, because again I'm going to multiply 2y plus x by denominator and the numerator, so it's going to be negative 6y squared minus negative 3y times x is going to be negative 3xy, and then I'm going to rewrite the rest minus 6x squared minus 3xy. So now I'm going to continue. So let's see. Let's see if I can finish here. So I'm going to finish this here. So okay guys, if I divide this, the whole numerator, so look, this is the whole numerator divided by the denominator, okay? So I keep the numerator as the way it is, divided by the denominator, that the denominator is going to be over 1, okay? So now, if I keep the first thing as the way it is, the numerator, times and flip the second one, so obviously I'm going to have so let me ask you guys this. So I can rewrite this as negative 6x squared. Okay, guys, negative 3xy minus 3xy is going to be negative 6xy, and then minus 6y squared. Okay, and then over 2y plus x squared. So now I can factor out negative 6. So if I factor out negative 6, it's going to be negative 6 times x squared plus xy plus y squared over, this is actually cube, because if I multiply, so if this is a numerator divided by the denominator, so, and then if you keep the numerator as the way it is, multiply, we flip the second one, so it's going to be, this is going to be cube. Sorry about that, guys. So I factor out negative 6, so it's going to be x squared plus xy plus y squared over 2y plus x cubed. Okay, guys, now let's go back to here. Again, guys, what was x squared plus xy plus y squared equal to? Equal to 3, correct? So I can now replace this by, so again, guys, replace this by 3. So it's going to be negative 6. Instead of x squared plus xy plus y squared, I'm going to just say 3 over 2y plus x cubed. So negative 6 times 3 is 18. So it's going to be negative 18. So it's going to be negative 18 over 2y plus x cubed. So this is actually y double prime. So I know, guys, this is complicated, but please, guys, take your time, work on it. If you have any question, you guys can ask me later on through the discussion board, or I'm going to work on it, see if we can come up with an idea, so we can just help you guys, probably using the Zoom or other stuff, so we can work together. So so this is it. So now let's go to the last part of the 3.5. So derivative of an inverse trigonometric function. So the derivative of respect to x of sine inverse of x is going to be 1 over square root of 1 minus x squared, when x cannot be positive 1 and negative 1, obviously, because if I put 1 or negative 1 instead of x is, so negative 1 or 1 squared is 1, 1 minus 1 is 0, so the square root of 0 is 0, and we cannot have a 0 in the denominator because make everything undefined. And then you guys can see the rest, derivative of respect to x of cosine inverse of x and tangent inverse of x, and so on and so forth. So let's first I'm going to do derivative of respect to x of sine inverse of x, how we reach to 1 over a square root of 1 minus x squared, and I just do that one, and then you guys can like do later on by yourself how you guys can do the tangent inverse of x. And again guys, it is all in your book, so you guys can see your book also. So let me do the sine inverse of x. So first of all, this is actually y equal to sine inverse of x. Okay, that actually means that sine of y is equal to x. And then we know, by again back to the trigonometric class, we know that y, in this case, y is greater than or equal negative pi over 2. So it's greater than or equal negative pi over 2 and less than or equal pi over 2. Okay, so now we're going to differentiate sine of y equal to x implicitly with the respect to x. So again, I'm going to take a derivative of sine of y. So sine of y is going to be cosine of y. So the derivative of mother and then derivative of baby. So and again guys, because this is a function of y, because we take a derivative respect to x, so the cosine of y, the sine of y is cosine of y, and then the baby is 1. So but again, because this is a dy dx, so I'm going to just say y prime equal to, and then the derivative of respect to x of x is just 1. And again, I'm going to isolate the y prime. So divided both sides by cosine of y. So it's going to be y prime equal to 1 over cosine of y. So now remember that the mother formula for the trigonometric function was sine a square of y plus cosine a square of y equal to 1. So I can just say, oh, cosine a square of y is equal to 1 minus sine a square of y. And then we know, let me just write it down here in the side. So the cosine of y is greater than or equal 0. Why? Since we know that the y is between negative pi over 2 and pi over 2. So we know that the cosine of y is greater than or equal 0. So when we take a square root of both sides, so the cosine of y, so the cosine of y is equal to a square root of 1 minus sine a square of y. So, oh, wait a minute. Remember that here I just say sine of y equal to x. So this is sine a square of y. So it's going to be equal to 1 minus sine of y is x, is going to be x squared. So finally, y prime is equal to 1 over the square root of 1 minus x squared. So that's why we find this. So now let's continue. So find the derivative of y equal to tangent inverse of x squared. So I'm going to do this again. Again, y equal to tangent inverse of x squared. So in fact, this is actually is tangent of y equal to x squared. So now I'm going to take a derivative of both sides. So the derivative of tangent y is going to be again tangent y, so it's going to be secant a square of y prime. So again, take a derivative of mother and then take a derivative of baby. Y is equal 1. But again, because we take a derivative of the y function, so it's going to be y prime. So secant square of y prime equal to, and derivative of x squared is going to be just 2x. And again, I'm going to isolate the y prime. So divided both sides by secant square of y. So y prime equal to 2x over secant square of y. So again, guys, by trig identity, we know that the secant square of y is 2x. So 2x over secant square of y, we can rewrite it as 1 plus tangent a square of y equal to, so again, guys, this is a trig identity. Again, you guys can use the trig identity to find that. So secant square of y is equal to 1 plus tangent square of y. So equal to, and again, guys, since tangent of y is x squared, so is going to be 2x over 1 plus tangent of y is x squared, and then tangent square of y. So whatever tangent of y is we have to square it. So it's going to be, the final answer is 2x over 1 plus 2 times 2 is 4. So x to the power of 4. So 2x for the derivative of y equal to tangent inverse of x squared is going to be 2x over 1 plus x to the 4. And then let's move to the last one and we're done for today lecture. So find the derivative of g of x of arc cosine of x. So let's do that one. So, and then we're done with the 3.5. So again, this is actually equivalent to y equal to cosine inverse of square root of x. So this is, in fact, this is cosine of y equal to square root of x. Now I'm going to take a derivative respect to x of the both sides. So again, the cosine of y, take a derivative of mother and then the baby. So cosine of y is going to be negative sine of y and then times y prime. The baby is 1, and then again, because we are we take a derivative of function of y with respect to x, so it's going to be dy dx. The other word is y prime. So equal to, this is take a derivative of a square root of x, so it's going to be 1 over 2 rad x. Again, why? Because look, let me write it in the corner. So this is x, the square root of x, actually x to the power of 1/2. And when we take a derivative, so it's going to be 1/2 x, and 1/2 minus 1 is going to be negative 1/2. And again, if I simplify this, going to be 1 over 2 rad x. So now I'm going to, again, I'm going to isolate the y prime. So I'm going to divide both sides by a negative sine y. So divide both sides by negative sine y. So this is gone. So y prime equal to, okay guys, again, this is my numerator and this is my denominator. So numerator, keep the numerator as the way it is, divided by the denominator, but keep the numerator as the way it is. Change the division to multiplication, flip the second one, so it's going to be so let me actually make it, so let's write it here. So y prime equal to 1 over 2 rad x times, and then flip the second one, so it's going to be 1 over negative sine of y, so is equal to negative 1 over 2 rad x times sine of y. So again guys, the so the y prime is going to be negative 1 over 2 rad x times sine of y. So now let me see what the sine of y is. And again guys, I'm going to use my trig identity. My friend is sine square of y plus cosine square of y equal to 1. So now I'm going to isolate sine square of y. So it's going to be sine square of y equal to 1 minus cosine square of y. And again, I'm going to take a square root of both sides. So again, sine of y, if I take a square root of both sides, sine of y equal to a square root of 1 minus cosine square of y. So again, guys, cosine of y is the square root of x. So it's going to be sine of y equal to a square root of 1 minus cosine of y square root of x. So it's going to be a square root of x. Cosine of y is the square root of x. And then cosine square of y, so it's going to be a squared. And obviously, the square root and the exponent, they cancel each other. So sine of y equal to square root of 1 minus x. So now I'm going to replace this. So y prime equal to negative 1 over 2 times square root of x times, instead of sine of y, I'm going to just write square root of 1 minus x. And finally, if I multiply square root of x times the square root of 1 minus x, so it's going to be y prime equal to negative 1 over 2 times the square root of x times 1 minus x. And that's it. Okay, guys, thank you so much for your patience. Again, guys, if you have any question about these lecture, make sure first watch these video for a couple of times, and then if you have any question, let me know. And again, guys, on Wednesday I'm going to do the discussion board, and then I give you guys some problems, so make sure you guys understand everything. Thank you, guys, and have a wonderful day. So later on I'm going to post the 3.6 and then 3.7. Thank you.